The process of making water faucets in China involves several steps, including casting, machining, polishing, electroplating, and assembly. Initiated by the casting process, which involves melting brass or other metals and pouring the molten metal into pre-shaped molds with predetermined designs. The molds are coated with a specific liquid and then fired to prevent cracking and leakage during the casting process. And also, preheating the mold before the casting process helps prevent thermal shock. This step ensures that the mold can withstand high temperatures during the pouring of molten metal. Brass or other metals are melted in a furnace. The molten metal will later be poured into the prepared mold to take the shape of a water faucet. After pouring, the molten metal cools and solidifies within the mold. This phase requires controlled cooling to avoid defects such as shrinkage or porosity. Next, the machining process involves the use of lathes, drills, and other equipment to shape and refine components. The next stage, before electroplating, involves thorough cleaning of faucet components to eliminate contaminants. This is typically done through a series of chemical cleaning and rinsing processes. Proper cleaning is crucial to ensuring the adhesion of the coated layer. Afterward, faucet components are immersed in the electroplating bath, and an electrical current is applied. This current causes metal ions in the solution to adhere to the surface of the components, forming a thin and uniform layer. The next stage is the polishing process. In the polishing process, the surface of faucet components is rubbed with abrasive materials. This can be done manually or using polishing machines. The goal is to gradually refine the surface, removing any scratches, marks, or uneven areas. In the final stage, assembly workers follow detailed assembly instructions that specify the order and method of assembling each component. Fixtures, such as valves, handles, and spouts, are installed in predetermined positions. This includes attaching hoses, tightening screws, and ensuring all parts are correctly installed. The automatic paper cup making machine process includes the printing process, cutting process, forming process, and the final stage of bottom forming, which is then followed by the drying process. The cut paper is then transferred to the forming station, where it is molded into the shape of a cup. The machine uses heat and pressure to achieve the desired cup form. The next stage is the bottom punching process. In this stage, the machine creates a hole in the center of the cup's base, thus creating the opening for the cup. As an estimate, modern automatic paper cup making machines can produce 100 to 200 cups per minute, depending on the machine's specifications. This translates to a production capacity of 6,000 to 12,000 cups per hour. Automatic sensors inspect the quality of each cup, ensuring it meets the specified standards. The finished cups are stacked and counted automatically, preparing them for packaging. Rotational molding, commonly known as rotomolding, is a plastic molding technique suitable for producing hollow products. The process begins by introducing the plastic raw material, usually in the form of powder, into the mold, typically made of aluminum or steel. After that, the mold filled with plastic is closed and rotated on 2 axes. This molding method differs from other techniques such as injection and extrusion molding because it does not involve the use of pressure forces. At present, approximately 97% of rotomolding products are made using polyethylene, one of the most versatile and easily moldable plastic raw materials. The mold is then heated in an oven while continuously rotating to melt the polymer inside. Once the polymer has completely melted, the mold undergoes a cooling process with the assistance of air or water. The cooled polymer will then take the shape of the interior of the mold and is subsequently ejected from the mold. Double-edged razors are currently used in various industries, including the hairdressing, textile, and bakery industries. The process begins by feeding the blade into a punching machine that will shape the entire blade. The punching machine is a high-speed machine, and the blade is stamped at a rate of 800 to 1,200 strokes per minute to form the intricate shape. Next, the double-edged blade needs to be hardened and strengthened through a heat treatment process. Then, it is cooled to obtain a strong and rigid physical structure. The now hardened blade is then passed through a printer that uses the brand name of the razor. After the product reaches optimal hardness, it is placed into a grinding and polishing machine. Inside, there are 3 grinding stations that sharpen the contours, producing 2 super sharp cutting edges. The blade then passes through a polishing station that removes any grinding residue left from the grinding process. The next process involves placing the original razor into a vacuum chamber. With this process, it will draw a chromium-based layer onto the surface, making the blade tip harder and more resistant. Next, a protective coating will be added to the blade through the sintering process, which functions to permanently bond the layer to the blade's surface. This process is carried out by baking the blade for 20 minutes at a temperature of 660 degrees Fahrenheit. Before entering the packing stage, the blade is immersed in organic oil for about half an hour, providing additional protection against corrosion. Corrosion is a major cause of blade damage. Blades typically only last for 4 or 5 shaves, but any additional protection from blade corrosion always helps. On the packaging line, the equipment individually wraps each blade with wax paper. The wax coating on the paper helps protect the razor from corrosion during storage.